Hello everyone, thanks for coming. Today we are going to do a review of our lectures in week 13. So first, we introduce the Stokes Theorem. The Stokes Theorem is a generalization of the Green's theorem for a plane curve. The Stokes Theorem applies to spatial curve. It states that the line-integral of a vector field on a spatial curve equals to the surface integral of the curl of the vector field. So it's generalized the 2D Green theorem to 3D spatial curve and the surface integral. First, and the conditions are that the surface should be orientable. Usually, the normal vector is pointing upward, and its boundary, which is a curve, is the orientation is counterclockwise. We talk about the divergence theorem. So the Green theorem, we can write it in a vector form. The line integral of a vector field f equals to the double integral of the inner product of the upward direction and the curl of the vector field. Here we interpret the vector field as a 3D object, 3D vector function. So if we extend the Green theorem to 3D, we may guess that the double integral, the surface integral, equals to a triple integral, and that's the divergence theorem. The surface integral of a 3D vector field on the boundary of a region equals to the triple integral of the gradient of the divergence of the vector field inside this region. So what is the meaning of the curl vector? What is the meaning of the divergence vector with the help of Stokes theorem and the divergence theorem? Actually, they have their clear implications in fluid dynamics. The meaning of the curl vector actually measures the circulation of the fluid along a circle that has a center that is a very small circle centered at the point P0. On the other hand, the divergence of a function also can measure the net flux inside or outside of the domain. So if the divergence of the vector field is greater than 0, we call the point to be a source. Otherwise, we call the point to be a sink. So the integration of divergence inside of the vector field inside the domain equals to the net flux, influx or outflux, over the boundary of the domain. So that's the implication of the divergence. Thanks for listening.